All right, this is the SAGE review. I'm hoping to get problems 1 through 25, the odd ones, done today with you. And then you can do the even ones on your own time as we go. You may want to pause and do the evens right after we do the odds, or whatever you want to do. Problems 1 through 25 are assigned, and you need to do them with or without the video. So hopefully you're watching like you're supposed to. Okay, so these first problems come from Unit 2, the very first unit we did this year. The instructions say, write each polynomial function in standard form, classify it by degree and number of terms, and determine the end behavior of the graph, both formally and informally. Lastly, find the turning points by finding the maximum minimum of the function. State the intervals and where the graph is increasing and decreasing. So a lot going on in this one problem. Here's our function. If I want to write it in standard form, that means I can't have parentheses here. So you have to remember how to square that. I hope that you all do. We'll rewrite that, x minus 3 squared. Ooh, that marker's right in your camera. Okay, x minus 3 squared is the same thing as x minus 3, x minus 3. Then you have that minus 2 off to the side. When you distribute that, you'll have x squared minus 3x minus 3x plus 9, and then you have that minus 2 from the side. So I've got x squared minus 6x plus 7. So that's what this is in standard form. Classifying it by degree, it's 2, so it's a quadratic. By the number of terms, there's 3 terms, so it's a trinomial. Just a reminder, if the degree was 1, it would be called linear, 2 is quadratic, 3 is cubic, and after that we're just going to say degree 4, degree 5, degree 6. By terms, if there was only 1 term, it's a monomial, 2 terms, binomial, 3 terms, trinomial, 4 would be quartic, and 5 would be quintic. Sorry, that took me a minute to remember. We usually only see 1, 2, and 3. Those are the most popular. Okay, so end behavior. This is the formal way to write it. As x approaches negative infinity, so x is going this way, what's y doing? It's going up, right? So it's going to infinity. And as x goes to positive infinity, y goes to positive infinity. Informally, what's happening to the left? My graph's going up, right? So end behavior informal is up. And to the right, again, it's going up. Up and up is what we used to describe that behavior. The turning point is right here at that minimum. The turning point is a minimum, and it is at 3, negative 2. It is increasing, this is the turning point, from 3 to infinity. It's going up. It's decreasing from negative infinity to the turning point, 3. Number 3, if I want to simplify this, it's amazing that this is what we were doing on the first unit, right? Then you combine that one with that one. We've come so far this year. You've done a lot of really hard math. This, I hope at this point, is not really hard math. Big thing with number 5 to remember to do, you have to make sure you distribute that negative. No parenthesis there, it's supposed to be. So this is supposed to be a negative 5x cubed, positive x squared, positive 2, and then we'll combine just like we did above. So I've got the 12 and the minus 5 make a 7x cubed. The minus 7x, the plus 1x would be a minus 6x squared plus 4x plus 2. Sorry, that's really bouncy. Write a polynomial function with the given zeros. So these are my zeros, which mean if we were writing them like this, x minus a negative 1 would be x plus 1, x minus a negative 1, x minus 6. You could write it like that. You could also write it as y equals x plus 1 squared, because there's two of them, times x minus 6. Perfect, nice and fast. Number 5, find the zeros of each function, state the multiplicity of the zeros, and describe how that multiplicity affects the graph. Number 9. So I've got two different groups right here, right? The 3x and the x plus 2 cubed. So 3x, x plus 2, those are my two different groups. The zeros, if I set that equal to 0, x would be 0. Divide by 3, x equals 0. If I set this equal to 0 and solve for x, x would be negative 2. The multiplicity on this first one, the degree here, there's only one x, so the multiplicity is 1. The degree here is 3. The multiplicity is 3. Now if you remember what happens when you have an even and an odd multiplicity, if I'm looking at my graph, an odd multiplicity is going to come down through it. An even multiplicity is going to kiss it and go back up. So both of those have an odd multiplicity. So 3x is going to cross at 0. And at the negative 2, it's going to cross. If that had been a 4, we would say kiss. Or it's going to touch. Might be a more technical term. All right, number 11, we're going to do the same thing, except for this time we have to be the one that factors it. So I notice that they all are multiples of 2. So we're going to pull a 2 out first, a 2x. When we rewrite, I've got a 2x squared minus x minus 1. Okay, so let's go off to the side. We need to set up the game for this. We need to find two numbers that multiply to negative 2. We use the negative 1 and the 2. So they multiply to negative 2. They add to negative 1. Multiply to negative 2, add to negative 1. Alright, so 2 is nice because there's only 1 and 2 that will work. If I want it to add to negative 1, the 2 has to be negative. Now anytime this number right here is anything other than a 1, we need to solve by or factor by grouping. To factor by grouping, I'm going to take this middle term right here and I'm going to use my game pieces, that's what I call these, to factor that. I'll rewrite, ignore this first 2x for a minute. That's still there, we just don't need it right now. Rewrite the 2x squared minus 2x, we get that from the first negative 2, plus x, we get that from that one, minus 1. Now we have that, we can group it. I'll group the first two, group the second two, pull out everything they have in common, and when I do, what's left should be exactly the same. So on the first group we have a 2x, and we're left with x minus 1. On the second one, we can't pull anything out, so I'm going to put a plus 1 so I don't forget that I'm pulling something out. In this case, it's just a 1. X minus 1. They both have an x minus 1 right here. If they don't, then you've done something wrong. They both have an x minus 1. We can pull that out. That's ugly. X minus 1. You can pull that out front. And we're left with a 2x plus 1. So that is this one factored. We still have that 2x out front. And very small off to the side, we have to come up with that chart. So in this one, our factors, we have a 2x, we have an x minus 1, and we have a 2x plus 1. If I set this equal to 0, x equals 0. If I set this one equal to 0, x equals 1. And if I set this equal to 0, we'll subtract the 1. And then we divide by 2. So x equals negative 1/2. Now the multiplicity on each of them, I don't have any duplicates. My multiplicity is 1, 1, and 1. Which means on all three of these zeros, all it's going to do is cross. and that's it. If you watch this, somebody come tell me if my voice just went robotic man voice right there, because I'm just curious if maybe I figured out why it's doing that. So if I just sounded like a man, come tell me. If I didn't, then that's an embarrassing conversation I'm having with myself right now. All right, moving on, number 13. We want to find the real or imaginary solutions to each equation by factoring. Fantastic, let's do this. In order to factor, we need to have everything on the one side. So I'm going to add the 24 over. Okay, add the 24 over. Then I can play the game. Hopefully it factors. I just got ready to factor. It may not. What are two numbers that multiply to 24 but add to negative 11? Well, they either need to be both positive or both negative to get a positive 24. This is negative, so if I multiplied negative 8 and negative 3, I should get it. That first number is a 1, so I don't have to factor by grouping like I did right here. I can simply say x minus 8, x minus 3. Now if I want to solve for that, I could set each of those equal to 0. So right here, if I set x minus 8 equals 0, x would be 8. And right here, if I set x minus 3 equal to 0, x would be 3. Look at it another way. If I plugged 8 in right there, I would get a 0, right? That's my solution. If I plugged a 3 in right there, I get a 0. That's my other solution. We are more than halfway done, so that's good. This is going to be a nice short video for you. Hopefully it doesn't take too much time. Okay, on this one, let's take that 27x over. And the first thing I'm going to do is I notice they each have a 3 and they each have an x, so let's pull that out front. 3x. We are left with x squared plus x minus 9 equals 0. This one we'll ignore for a minute. It's easy to solve. What do I plug in there to get to be 0? X equals 0. So that's my first solution. This one right here, if I try to play the game, what two numbers multiply to negative 9 and add to 1? There isn't one, right? Because my choices are 1 and 9, 3 and 3. Neither of those will add up to be 1. So you can't factor this, which means there's two ways to solve it. One is by completing the square, but most people have forgotten how to do that. So the other one is the quadratic formula. The quadratic formula says, hopefully you all get the song stuck in your head now. Quadratic formula, negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. The number inside the square root is called the discriminant. It tells us what kind of answers we're going to have. I'm going to plug that in. 1 squared minus 4 times a times c. I get a 37. It's positive, so I'm going to have real solutions. So let's rewrite that. X equals negative 1 plus or minus the square root of 37, which happens to be prime, over 2. Those are 2 out of my 3 answers. My other answer is going to come right here. Remember when we said if I plugged in a 0, I would get a 0? So x equals 0. Now, this is a degree 3 polynomial, which means I need to have 3 answers, do I? That's 1, and then that plus or minus makes this one 2 and 3. Moving on, number 17. Find the real roots of each equation by graphing. Fantastic. Conveniently, we can do that on our graphing calculator. So y equals, let me clear that out. Really quick, I'm going to make sure that was turned off from a previous assignment. Okay, so y equals x to the 4th plus 3x squared minus 2x plus 5. Oh, I hate when I do that. Does that bother anybody else? Drives me crazy. Let's try again. X to the 4th. Sorry, this might be painful to watch. 3x squared minus 2x plus 5. Now, if I want to find the real roots, you can't find any imaginary roots based on the graph. You can zoom out a little bit. Let's see what's going on here. It doesn't appear that it crosses the graph at all, which means if it doesn't cross the graph, there are no real roots. If it did cross the graph, we would find where it crossed the graph, and that's what x would equal. Nice. Number 19, the height and width of a rectangular prism are each 2 inches shorter than the length of the prism. So let's start by drawing it. We've got a rectangular prism. Okay, probably not the best rectangular prism we've ever seen, but that's all right. Something like that. The height and the width of a rectangular prism are each 2 inches shorter than the length. So let's call this the length. We'll say that's x. That means the height and the width are going to be 2 inches shorter. X minus 2, x minus 2. The volume of the prism is 40. Now, how do I find the volume of a rectangular prism? We just multiply them together. So it's equal to 40. Approximate the dimensions of the prism to the nearest hundredth. So here's how I do this one. 2 ways. Best way to do it is on the calculator, easiest way. We could solve this algebraically, but you all have graphing calculators, and so let me just show you how to do it on here. I'm going to go into y equals again. X times x minus 2 times x minus 2. And I want to see when my left part crosses the right part. So the next graph that we have to do is 40. Now, what is that going to look like? It's going to be a horizontal line clear up at 40. So I need to change my window so that my maximum is at least 40. So then I can see what's going on. I'm going to make that by 10s. I may have to change the window on the x values a little bit, but let's see what happens. Right there. So I want to know where these cross. You could trace it, but you may not get the best, if you trace it, you can get an approximation. I want to know when my red line crosses my blue line. What x value? So that's really close, 39.33. So we can say about 4.8, but I can't say exactly that. So go into calculate, which is the second trace button. I want to know the intersect. It's going to ask you a few questions. It's going to ask you where the first curve is. So right now I'm on the blue line. I just push enter. It asks me where the second curve is. I'm on the red line. Push, oop, not that. Garbage. Okay, try one more time. Calculate. I would edit this, but I don't have time. So you just have to deal with my mistakes. It's, again, probably painful to watch. First curve, second curve, and then we just have to guess. You can just push enter again. The intersection right there, when y is 40, x equals 4.87. That's all. So you can solve a lot of these using your graphing calculator. There's no point doing it by hand. I mean, you can't do the imaginary solutions. So questions 14, 16 up here, you probably should use your by hand, algebraically. But you can try graphing it. Let's see what happens. So that's just another strategy. Number 20, divide using long division. This is relatively miserable. I don't know if you remember it being miserable, but here's how you do it. No, it's not too bad. I just remember everybody hated it. Divide using long division. I will choose synthetic division almost every time over long division if I have a choice. But here's how you do it. You look at the x and you look at the x cubed. How many times is x? If I were to divide those two, x cubed over x would be x squared, right? Now the pattern for long division is divide, multiply, subtract, and then we're going to bring down, and then it repeats. Divide, multiply, subtract, bring down. So I just divided. Now I'm going to multiply. When I multiply, I've got x cubed and x squared. Then I subtract. In order to subtract, you change both of those signs and then combine them. Those will always cancel, always. Subtract those, you get 6x squared, and then we bring down the rest. Plus 15x plus 9, and we do it again. 6x squared divided by x would be a positive 6x. Multiply 6x times x would be 6x squared. 6x times 1 would be 6x. Subtract. In order to subtract, you have to change the sign. Cancel. You would get a 9x plus 9 when you brought that down. Last time, 9x divided by x is plus 9. 9 times x would be 9x. 9. Subtract, change the sign, and the remainder is 0. So if I had a remainder of something other than 0, like say it was a 1, I would come up here and I'd say plus 1 over x plus 1. If that was anything other than a 0, I would do something like that, but it wasn't, so this is my final answer. Number 22, divide using synthetic division. We like this one better. This is where I take this plus 5 right here and I do the opposite. It's like I'm solving. I'm going to make it a minus 5 right here. I'm going to use the coefficients of this and list them all. If there's any zeros, we need to list the zero. So it goes from cubed to squared to linear to the constant. So there's no missing pieces. Notice on number 23, I'm missing my x term. So you'll have a 0 in there for the x term. So 1, 5, negative 1, negative 5. You always bring down that first number, and then you multiply, add, multiply, add, multiply, add until you're done. So 1 times a negative 5 is negative 5. Add, you get 0. Multiply, you get 0. Add, you get negative 1. Multiply, you get 5. Add, you get 0. So my final answer is always 1 less than you originated, because I'm dividing that linear term out. So it would be x squared. There's no x term, minus 1. Now if we had to, we could factor that. That's the difference of squares. If I was trying to divide everything out, that would be a difference of squares. We're almost finished here. Number 24, determine whether each binomial is a factor. So if I want to know if that's a factor, I want to know if I plug in x equals 2, which is the opposite of the minus 2, if I plug that into here, do I get 0? If I get 0, yes, it's a factor. If I don't get 0, then no, it's not a factor. So plugging that in, 2 cubed plus 2 squared minus 10 times 2 plus 8. 2 cubed is 8. 2 squared is 4 minus 20 plus 8. Let's see, that's 12. 20 minus 20, you get 0. So is this a factor? I'm going to say yes, it is. All right, we are finished with today. 23 minutes, that's not too bad. Make sure you have this assignment done before we take the SAGE test on the 3rd. We have done the first 25 here right now, the odds, you do the evens. Then in class today, you should have done a bunch more. Hopefully we're well underway. And if you come and tell me that you watched this, then I will give you extra credit. You just have to tell me what your favorite color is. You come up and tell me what your favorite color is, I'll know that you watched this video. All right, peace out.